And with this introduction, welcome to week 5 of our AC/DC portion. And obviously, this section of our video today is brought to you by AC/DC, because that is what we're going to be covering. And I figured it was appropriate to have them lead us off into the introduction of the circuit topic discussion today. So hopefully you enjoyed that, and hopefully YouTube doesn't take it down because I used a clip from copyrighted music. I am giving credit that it is AC/DC, so hopefully that flies. If it gets changed around or whatnot, I will let you know, and we'll kind of go from there. I just thought it was kind of fun to use that introduction. One of my more favorite songs from AC/DC is the Thunderstruck. So anyway, so let's get right into today's topic. So like I said, we're going to be talking about AC/DC circuits. Now, this isn't the band, this isn't, anything like that. It's we're combining alternating current and direct current together, and so now, now we've had a chance to kind of play with it, see what AC does. Now we're going to put this to use. So, as a quick reminder, what we have is we have two types of signals. We have an AC signal, which is an alternating signal. We have a voltage peak. We have our period from here to here, which is measured in time, and it's 1 over the frequency. We have all these different parameters. We have the positive iteration. We have the negative iteration. We have our zero line. That's probably the biggest thing that we need to look at is when we have this is going to be our zero line. Now, normally when we do a signal, this is what we have. We don't have any kind of DC offsets. We don't have anything like that. So then we also have our DC line. So remember, this is AC, and then our DC line is we have 0 volts, and then we have a voltage here that's constant, doesn't change. And so this instance, we'll just say it's 5 volts. And over here on our AC signal, we have a 5-volt peak signal. So now, one of the things we need to do is when we're working with these two values, when we start combining them together, we want to make sure that we list the DC portion, specifically so we can find it, and vice versa with the AC. So with the AC signal, it's pretty easy because we have our 5-volt peak, we have 5-volt peak to peak, we have RMS. We've got the different designators that we use already. And then just so we don't accidentally mix things out, when we're talking about the DC portions, we can just label them as VDC. Just as a quick real visual reminder for us that we're talking about the DC voltage versus the AC voltage for any of the situations that arise. So now the idea behind this is when we have our AC signal, we have our DC signal. These are values that we can go through and we can calculate normally based on any type of circuit that we're working on. That's kind of the whole point is we've given you guys an introduction to all the different components and what's going to happen when I put these signals with them. Well, now what we're going to be doing is we're going to be combining these two guys together. So if we take an AC signal and we take a DC signal and we combine them together, what we're going to get is we're still going to get our DC signal, our AC signal, and it's going to be looking just like this. But what we've done now is we've shifted where the center line sits. So before, this was sitting at 0 volts. Now with the signal, with the same values that we have before, our AC signal is now centered and is now riding on a 5-volt signal. And so what we have is we have a plus and minus 5 volts over top and underneath of this 5-volt DC signal. So now when we go through and we do that, we're going to have a max value of 10 volts peak, and we're going to have a minimum value of 0 volts peak. So we're still maintaining our 10 volt peak to peak signal. We're still maintaining our 5-volt peak signal, but now we've just shifted it from 0 up to 5 volts. So before, like with our AC signal, we had a 10-volt peak-to-peak signal. We had a plus 5 volts as the max, we had a negative 5 volts as the minimum. But when we combine these guys together, we end up with the same parameters other than our min and our max voltage are going to change as we progress. And so that's kind of the whole idea is we're going to solve these guys independently with our DC and our AC portions, and then we're going to combine them together at the end to shift us and give us our min and our max new outputs. The reason that we're learning about this and going behind because we have signals that we cross all the time. Sometimes we want an AC signal, but we don't want it to go into the negative voltage. It may throw a motor in the reverse direction where we don't want it to, but maybe we just want it to come up to a voltage and we want it to speed up, then we want it to slow down. Then we want it to speed up, and then we want it to slow down. And so we do that. That way we have this control, but now it's not going to speed up, slow down, reverse, go faster in the reverse direction, slow down. And now we've shifted it to something that's a little bit more useful for us. One of the things too that we're going to be looking at is now on our scopes, the coupling is going to be a lot more important. So when we talk about coupling on our scopes, we have a couple of different options. We have AC coupling, we have DC coupling, and we have ground. So now basically what we're looking for on this one is we've been using one or the other. So AC coupling, this shows us just the AC portion. No DC offset. So this is what we've been using for all the previous labs because we don't care if there's any kind of DC shift. We just want to see what is my AC portion of the signal doing. So now when we shift into our DC mode, what this shows us our AC waveform with the included voltage shift. So this now, like I said, this gives us the opportunity to move this waveform around as we need it. One of the biggest examples, like I said, is if you have a motor, you want it to periodically speed up and slow down, but you don't want it to reverse directions. Okay. So now that we have the, have kind of an understanding of what these couplings are going to do, and you'll see this. You'll switch back and forth between your couplings, especially next week when we start talking about power supplies. There's going to be times where you want to see just your AC portion because comparatively, you may have a signal that's 45 volts DC, but you have like a 200 millivolt signal riding on there. And to see everything, to get it all on the screen, you're going to have to change your volts per division very, very large. So it's going to hide the AC signal, or what we call ripple. It's going to hide that signal. So then you want to just look at just the AC portion to see, okay, well, what is this doing so I can get my min and my max voltages? And because that's how power supplies are rated. It's the voltage ratings they can get to, but it's also the amount of ripple that they have. So a higher power or a higher cost power supply is going to have less ripple than anything else. All right, so a couple more things to talk about is, so that's the coupling that we use on our scope. So the next part that we have is called a coupling capacitor. So as we remember, with a capacitor, when we hook it up to a DC signal, it's going to charge up to some value, and then once it reaches that value, it doesn't charge anymore, and then it essentially acts as an open. It's the same thing here. What it does, it's going to charge up to a value, but then it's going to block DC signals from getting past it. So what essentially it's doing is it's filtering out DC signals from reaching certain parts of the circuit. Now we use these primarily to connect up into our AC generator into the circuit, so that way we're not throwing DC signals back into the generator and causing loading effects down there. So it's one nice thing is it eliminates the generators from, or it isolates the generators from each other, one DC, one AC, so that they don't mix, and so we don't lose any of our signal into the generator. We have it for the rest of our system. So that's the big thing is we have a coupling capacitor. It blocks DC signals from passing through the component. It charges up and it basically becomes an open. And we'll talk a little bit more about that as we get going. Where we use these. The other thing that we have is a bypass cap. Now what this does, this ends up being when a capacitor, so at high frequencies, its X of C value becomes very, very small. So then what we do is we put this in parallel with a component to basically hide that component from AC signals because it's going to take the path of least resistance. So it's used to hide components from AC signals. So kind of like with the coupling capacitor, it hides anything past it from the DC. The DC doesn't even know it's there. The bypass capacitor hides components and hides parts of the circuit from the AC portion because basically what it does is it puts a very, very small resistance in parallel with it to ground, which then essentially shorts out that component from the AC, making it so there's no voltage drop. We're not seeing it. It comes in very, very handy when we want, when we want to, hide things from the AC signals, when we want to boost, give a bigger portion of the AC signal to our output. And this is going to come in handy and a lot more used next semester when you guys are talking about amplifiers. We use bypass capacitors all the time. We need the resistance in there to bias it correctly with the DC part, and then when we throw the AC signal in, we want that gone so we can get as much gain out of our amplifiers as possible. So that's kind of the idea behind those. So with that, we're going to kind of go through a circuit and we're going to talk about these different components and we're going to solve for, what are we actually looking at in our outputs. And what I think I'll do is I think I'm going to go ahead and break here and just do this as an introduction. And then I will do my next video where we start in onto the circuit analysis for AC/DC circuits. So with that, go ahead and hang on and I will get the next video going here shortly.